Hi friends, it's Mrs. Drake. So welcome to what will be our classroom as long as our classroom is on YouTube. So you'll see that it has me, it has pictures and maps, and it also has drawings that you guys have done. Now, not everyone's is up there because A, I don't got enough room, and B, and most importantly, some of your drawings have your names very prominently, and though I really love knowing who made a drawing, I can't show your names on the internet for privacy reasons. So I will be making sure to keep personal names out for that reason. We will be doing our math class here. The way that it's going to work is I will give you one or two problems to work on. You're going to pause the video when I tell you to, do the work, and when you pull it back up, we'll go over the problem together. Now, if you hadn't guessed, this is my first series of times. The read aloud was actually the very first time I ever made a video for YouTube. So there will be issues, and I will learn and get better. And before you know it, I will be a famous YouTuber. So let's go ahead and get started. We were talking about fractions before we left. Just for the record, I miss you guys so much, and I did not realize when we left the other Friday that it would be the last time we'd see each other for a few weeks. And I really cannot wait to see all of you again. It will be sooner than you think, and I know this stuff is super weird, but that's okay. Life is pretty weird. So now we're getting started. We were talking about fractions. We're going to kind of rewind a little bit and then go over all of our fractions thing. The first thing I want to talk about though is to remind ourselves what kind of is our basis with fractions. And the way we started fractions this year was talking about equivalent fractions. Now, equivalent fractions, you might remember, equivalent means the same, and fraction is an equal part of a whole. So equivalent fractions are fractions that show the same amount of the whole being taken, even if their numerator and denominator is different. It represents the same amount. So I'm going to present a problem, and then I'm going to have you pause the video to work on it. So our first problem is this. And it's backwards because that's the nature of video. Jaden and Neshka are making sure to read at home every day. They are reading the same book. Neshka has finished 1/4 of the book, and Jaden has finished 2/8 of the book. Who read more? Show your work. So once again, that's Jaden and Neshka are making sure to read at home every day. They are reading the same book. Neshka has finished 1/4 of the book, and Jaden has finished 2/8 of the book. Who read more? Show your work. Now, please pause the video. All right, I hope you got some good work done. Just to let you know, we have another classmate here. This is Olga. She is the best dog in the entire world, and she will probably come in and yell at me for not petting her sometimes. She really does. She goes, rawr, 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 rawr. So, anyway, our question was, Jaden and Neshka are making sure to read at home every day. They are reading the same book. Neshka has finished 1/4 of the book, and Jaden has finished 2/8 of the book. Who read more? Show your work. So, Neshka finished reading 1/4 of the book. So I shaded in 1/4 of my area model to show my fraction. So this whole section is 1/4 I know it's 1/4 because there are 4 equal parts in the whole. So 4 is my denominator. One part is shaded, so 1 is my numerator, 1/4. Then I also made an area model to show how much Jaden had read. It shows me 2/8. I know it's 2/8 because there are 8 equal parts in my whole, meaning that 8 is my denominator. And 2 parts are shaded, meaning that 2 is my numerator. I'm also sorry if these numbers are backwards. It's just like being with me in small group when I write upside down. So, 2/8, 2 equal parts shaded of 8 equal parts in the whole, 1/4, 1 equal part shaded of 4 equal parts in the whole. So when we look at these, we can kind of see already that they look like they're equivalent. However, we need to double check because, as we all know, sometimes our models aren't perfect. And if they aren't perfectly aligned, it can be really easy to miss whether something is equivalent or not if they're very similar. So, we have our models, but now we're going to show our work. So the way I like to do that, as you know, is I like to multiply. I like to check my work by thinking about first which of these would fit into the other. Now I know that I can fit 4 into 8 2 equal times. So I'm going to multiply my 1/4 by a whole represented by the same numerator and denominator. I'm going to multiply 1/4 by that one whole to find the equivalent fraction in eighths. Now I know that to get from 4 to 8 I have to multiply by 2 because 8 is 2 whole groups of 4. Okay. 4 times 2, definitely 8, but I still have these blank spots. I still have to figure that out. However, I know that if I'm multiplying to find an equivalent, I'm always multiplying by one whole. Why? Because any number times 1 is itself. And we're still looking for the same number, just represented by a different numerator and denominator. So if I'm multiplying by one whole and my denominator's 2, it means my numerator is also 2. When we multiply to find equivalence, our numerator and denominator stay the same. So now I have 1/4 times 2 over 2. 4 times 2 equals 8, so I know 8's my denominator, and 1 times 2 equals 2. So I now know that 1/4 is, for sure, equivalent to 2/8. So I know that Neshka and Jaden have read the exact same amount. Congratulations. All right. When we're talking about equivalent fractions, remember, an equivalent fraction simply means taking up the same amount of space in the whole. Two fractions cannot be equivalent if they don't take up the same amount of space in the whole. They also can't be equivalent if the wholes are different. If this was a trapezoid and this was a star, I couldn't compare them, could I? So, we're going to talk about equivalent fractions 1 or 2 more times this week. And I look forward to seeing you on here again. I miss you all very much. And we will look into ways for you to submit your work or send in questions or comments to me. See you next time.